When I left secondary school, I applied to do a science degree. And it was actually very good, the structure at the university I went to, because you could study science in the first year and you could pick multiple subjects. So it wasn't just physics or just chemistry. So I studied chemistry, physics, and mathematics. And the physics was about experimental and theoretical physics. And as a 4-year degree program, and in the first year you could do 4 subjects, the second year 3. And then the last 2 years you would specialize. And that's what I did. And so it was good because I had the exposure to chemistry and mathematics, which are things I liked from secondary school, and also the physics. And as time went by, it really, the physics then was the thing that resonated with me the most. So being in the laboratories, of course I was in chemistry laboratories, where things explode and smell. I was in physics laboratories where things generally don't work, or you electrocute yourself. That was for me more exciting. And so the physics laboratories were really the things that said, yeah, this is what I wanted to do. The idea of having an equation on paper, understanding a little bit about the theory of what the physics of that equation tries to quantify, it was interesting. But for me then more interesting was going into the laboratory and measuring that. And verifying for myself, that this is how nature works. This is physics. It's quantifiable. It's understandable. We can make theories. We can measure them and verify them. This to me was highly appealing, because this is a framework for answering bigger questions. How does the universe work? Why are we here? And these kind of things, which I think is what I'm doing now, working for the science program within ESA. I think I entered space later than probably most people would have. The physics I did for my PhD was not related to space science. Then after my PhD, I received an offer to do a postdoctoral research fellowship in the US. That was at the Jet Propulsion Laboratory. I didn't go there originally to do space science, but when I was there, I was, of course, completely surrounded by space. The science side of space, what are black holes? Is there water on the moons of Jupiter? I was surrounded by that, but also by the technology of space, which is what I'm interested in. I was also surrounded by that there, and that's really where I became interested in space as a career, and then decided, yes, this is what I'm going to work towards. So after university, you have different choices. Some people have had enough and they want to go and just get a job and work and have money. Other people, have the burning desire to continue in science. For me, it was kind of a little bit of both. I wanted to have a career path and also work in science, but more so in the technology side of science. So then I started to look around at opportunities, and a common thing to do is a postdoctoral research fellowship, a postdoc, which is a way of expanding on your expertise that you gain during your PhD, and usually is seen as a stepping stone to a career, usually academic, but also in terms of an industrial job. And so for me, that's what I did, was postdoctoral research work for a number of years. I also did lecturing at universities, and I also did working for an aerospace company in the UK before coming to join the European Space Agency. So at the moment, a major emphasis and a very exciting time for us working here at the Space Agency is preparing the technology for the Athena mission. So Athena is a X-ray observatory, which we are working on here at the agency and with the member states, preparing the instrumentation. This is a very large, highly capable telescope, which will take pictures of the sky, but in X-rays. So most people or a lot of people would be familiar with the likes of the images that the Hubble Space Telescope would produce, which are beautiful pictures of the stars, of the sky, galaxies, taken in visible and infrared light. So the light, visible light, the same light as you can see with your eye. We're building a telescope to make similar measurements, but looking at in the X-ray. And X-ray is very interesting because X-ray light is light coming from very energetic places in the universe. And so by taking pictures, photographs in X-rays, we can learn an awful lot about the energetic universe, things that are not visible to us with other telescopes. And this is a very exciting time. ESA is responsible for developing the optics technology, and I'm partially involved with that.